Thanks, and also welcome for me. It's great that so many people are interested in security. I want to talk about how you can protect yourself against security vulnerabilities that you may not even know about that you have, and how to do this without hating yourself in the process. A bit of background about me. My name is Bastian. Thanks for the introduction. I work for a company called SUSE. If you may have heard of SUSE by us providing enterprise Linux for the last 30 years. I'm not working at Linux at all. I'm working at everything that has to do with containers. So if you want to have questions about Linux, I just know the people to talk to. And the reason why I thought it's a good idea to talk about containers and security, more and more applications nowadays are running in production inside of containers. Who is running containers in production here? Hands, show of hands. Okay, this is a large majority. Who's running it on any kind of like single node container runtime things like Podman, Docker, Containerd, whatever? And who's running something in an orchestration system that could be Swarm, Kubernetes, Nomad, something like this? Okay, so half-half. It's also my experience when I talk with companies, which is mostly larger enterprises, that more and more applications are going to put into production running inside of containers just to benefit of the encapsulation that containers have, the automation that is in the ecosystem around that you don't have to create deployment scripts, monitoring system individually for every technology stack you're running. You have like a common API. You can integrate much easier with external systems, CI/CD systems, but also security systems. And don't get hung up on these numbers here. They are probably like 2 years old and probably wrong because they're as good as polling numbers on that get. But gist of it is more and more applications are running in production in containers. And also that may now be a bit more of my bias because I'm using a lot of Kubernetes and talking a lot about Kubernetes. A lot of these applications in productions are also running in Kubernetes clusters so that you don't have to think about individual machines anymore and where to run which container and which application, but more about a complete cluster and then Kubernetes, regardless of the infrastructure below this, data center, on-premise, developer laptop, cloud, handles everything from starting and stopping containers, load balancing, service discovery, networking, role-based access control, storage, and a lot of other things with common APIs. And Kubernetes, or same is true also for other orchestration systems like Swarm or Nomad, they are kind of great if you have like 1 or 2 clusters somewhere where you run your applications in. What I see though sometimes is, especially in larger enterprises, larger companies, that you end up in the end not running 1 or 2 clusters. You end up more with this kind of picture. You have multiple clusters for multiple development environments, staging systems. Every team has their own cluster somewhere. You may have multiple data centers. And Kubernetes or other orchestration systems can become quite ubiquitous. That on the one hand means it's also a target for attackers. You have a common API that is running that is managing the software that is running in a lot of different organizations and that works the same everywhere. That means if you find a vulnerability inside of Kubernetes, you have a massive attack surface across lots of organizations. So it is important to secure your orchestration systems on the one hand, but it's also important to have a look at the applications and the containers running inside of them and also what risks they pose. And that can become quite challenging in terms of security. So here you can see there is kind of like a graph of a Kubernetes cluster, very simplified. And traditionally, if you think about security tools, you have maybe a firewall in front of your system. You maybe have AWS security groups, like a hardware firewall, whatever. And with traditional security tools, you try to block access from the outside somehow. But then inside of your environment, basically everything is by default untrusted. Everyone can talk with each other. It's actually one of the concepts of this orchestration system. But that means if someone gets into here, they can basically do everything and also find other security vulnerabilities. The other thing is that, first of all, traditional security tools don't handle the dynamic nature of a Kubernetes orchestration cluster very well, because sometimes a container can run on this machine, then it can run on this machine, it gets scaled up horizontally, it gets scaled down horizontally, maybe a virtual machine breaks at some point, then everything gets scheduled somewhere else. All the IP addresses of all the pods constantly change, so you can't also just create firewall rules somewhere allowing this IP to talk with this IP, and you also don't have any visibility into these network systems as well. So that can become quite challenging. The goal there is to solve these challenges, to think about what to trust, not only to have like a trust system around your whole system to the outside, but actually have every container as its own trust boundary, so that you only specifically allow behavior inside of the container that is normal and block basically everything else, creating a zero trust system. So this is kind of like the idea, and let's dive now a bit deeper into it, how you can actually do this, and give you some examples. When talking about security in these systems, just to mention it, you also have still to think about the Kubernetes cluster and the orchestration system. That is not the main part of this presentation, but I just wanted to give you some ideas what to look out for. You should limit the API access to the API of orchestration system. You have to think about role-based access control, managing TLS certificates and internal certificates, keeping versions up to date to also fix bugs and patch things and vulnerabilities in the orchestration system itself. And you can think about security policies and admission controls to limit what containers can do in the orchestration system. Again, not the main part of this presentation, but just to give you an idea about a couple tools that can help with that, to make it easier to manage different orchestration systems and manage all the policies with them and keep everything, especially if it gets larger and larger, up and compliant. But the main point for this talk is more what to do about your applications, because there's also tons of things that can be in there. It could be that your application and your containers have way too much capabilities. They don't usually need to run as root the processes inside of the container, but oftentimes they do. They don't need to change something on this host's network stack, but oftentimes they actually have the capability there, so you should limit that. Then there's all these security vulnerabilities and CVEs that you can have either in the base images or in the packages that you install inside of your image as dependencies of your software, or in the frameworks and libraries that you're using. And then on top of that, there are also bugs that you created yourself in your software that can also impact security quite heavily. Tools that you can use to help you maybe with finding out how bad the situation actually is in terms of vulnerabilities and how to protect against them. A couple here, that could be Aqua, Sysdig, Stackroot, Snyk, NeuVector, and there's probably like 10 more that I forgot. The one tool I want to show you today and demo a bit for you is called NeuVector. Two reasons. First of all, I know it best because it's one that we are maintaining, but most important reason is it's open source and you can start using it for free like directly after the talk or on Friday if you want to. So what all of these tools have in common is that they target application security on two layers. The first one is the whole supply chain. So how do your application containers get built, and how you can ensure that what you are deploying into your clusters on production has as little security vulnerabilities as possible that you know about. And the second one then is what happens at runtime. So what happens when your applications are already online and running, how you can notice that there are new security vulnerabilities popping up, and if you can't patch them directly, how can you protect your system against the security vulnerabilities so if an attacker can come in somehow, they cannot do anything. It's all about zero trust runtime security. Let's start with a simple, or more simple thing. First, supply chain security. A typical supply chain looks like this. The developer, they write some code, and at some point they're happy with the current state and committed to some kind of version control system, usually Git. And then usually some kind of CI/CD pipeline starts running, it executes some tests, and then builds a container image. And that is the first point where you can integrate these security systems. You can directly integrate them into your CI/CD pipeline, and if you build your container image, you can scan it, and if there's a security vulnerability that the system knows about already, you get an alert, or maybe the build fails, or the developer gets a notification saying, hey, you should update something here that is insecure. Next step then is that the build image, usually if the build passes, is pushed to a container registry. Either something you host yourself in your own infrastructure, something in the cloud, private or public, doesn't matter. And there also, the security system can hook in and then continuously scan all the images that are already in the registry if there are now new security vulnerabilities that popped up. Because maybe you build it, everything was fine, 2 weeks later you want to be notified there is a new security vulnerability in something in your registry. And then, at some point, you want to put your application into production. If you run things in Kubernetes, the first entry point there where there is a hook-in possibility is the Kubernetes admission controller. So the Kubernetes API has some basically webhooks you can activate, and every time you want to deploy something new, some software can receive this webhook, and you get the whole specification what you want to do as a developer against the API, and then the software where the webhook goes to can say, yes, that's fine, or no, it's not fine. And then if it's not fine, the actual creation of a new deployment, the creation of a new container is completely blocked. And NeuVector can hook in there, and then you can configure rules, for example, saying, hey, please forbid the actual deployment of container images that already have known security vulnerabilities. Or maybe not block it, but only alert it so that you know about this, right? Or you could make this even more complex and saying, hey, maybe block the deployment of container images with more than 5 high-severity known security vulnerabilities that are older than 7 days and already have patches. Because if there are no patches, and if it is only like a 0 day or something, nobody had the time to patch it yet. If it's like a medium severity, maybe it's not that urgent and you don't want to block the deployment, you only want to know about it. And depending on your processes and use cases, you can configure it to your liking. And then last step, at some point, the application is actually running inside of your cluster, and then you also want to be notified if a new security vulnerability pops up. And I have the NeuVector logos here, but the other security tools do this very similarly. And scanning all your container images during the whole supply chain is important, because otherwise your security strategy is basically, I don't see it, so it doesn't exist. Kids can do this, but for actually running something inside production, I would say that's bad. But just scanning images as a security strategy is definitely not enough. What happens if there is a vulnerability that hasn't been even announced yet, but already is exploited in the wild? What happens if it's like a 0 day and it's announced somewhere Saturday night when no one is working, and you only see this on Monday morning, but between them it could already be exploited? What happens if you know about the CVE or the problem, but you can't directly patch it because there's no patch yet available? Or maybe the development team is completely understaffed that is responsible for this application. Or maybe you need to update a library, but in order to update the library, you have to refactor your whole source code for 2 weeks. And can you take the application offline during these 2 weeks? Probably not, because it's online for a reason, it makes money, and taking it offline would hurt the business or maybe even bankrupt it. Or maybe it is not even a announced CVE that is a security problem, but a bug that you yourself wrote in your software, and then maybe you have the possibility to find this with static analysis, but probably most scanners never will find like a logical bug in your software that people can use then to exploit and create an attack vector. So scanning images is important, but it never will be enough. There will always be cases where you are running something in production that has security vulnerabilities that you know or don't know about, and you have to deal with it. And that's where runtime security comes in. And runtime security can be thought about also on two different ways. The first is to protect against things and threats that you know about. This is like the classical CVEs that we just talked about. That could be also things like classical network attacks, SQL injections, cross-site scripting, Log4j, Log4Shell attacks. That was very prominent last year. These are the things you can protect about that you know, for example, by creating web application firewall rules, scanning the traffic inside of your system, and then if you see like a known Log4Shell payload, for example, directly block the request before it even reaches your application. The more interesting stuff is to protect against things that you don't know about yet, threats that you don't know about, or maybe threats where you not really can scan for it. There are attacks where you not by scanning the traffic you don't see them. They are more elaborate. And the idea there is to basically trust nothing in your system, to create a zero trust environment. And what that means is that you look for every application, for every container, what network connections are coming into the container and going out of the container, inside of your network, but also to external systems. What processes are you executing inside of a container? And what files are you accessing and writing inside of the container? And then you can build up a rule set based on this behavior. And you can say, only the things that are normal behavior that should happen should be allowed, and everything else should be blocked. Now, creating such rule sets, so basically it's firewall rules and process execution rules, right? Nothing completely magic, has been around for a couple decades already. But creating such a rule set can be a lot of work. At least I don't like configuring firewall rules. And then you deploy something new, something changes, a new microservice is introduced that you're talking to, and someone forgot to adapt the firewall rules and everything breaks. Or maybe the firewall rules are way too broad because you configured wrongly and then they actually don't do anything. They're just there, but attackers can still make elaborate attacks to access something else. One of the things where NeuVector can help there is by having an automated learning mechanism that creates all the rules for you. And then you can, for example, learn them, learn the standard behavior in a trusted environment, for example, in your staging system during testing. And then with security as code mechanisms or federation, you can push these rules that you learned in a trusted system to an untrusted system production, where an attacker could already be on. Let's look at this a bit more deeper. So here I have, again, a diagram of a simplified Kubernetes cluster. Could be also any other orchestration system with containers. And you can see lots of traffic happening here. You have communication between containers within a Kubernetes pod in this case. You also have internal cluster communication between these pods, and you also have communication from the outside. That could be the internet or intranet into the cluster, and also out again. So lots of communication happening there. With a security tool, you want to see network traffic-wise all of that. So you want to see the so-called east-west traffic within the cluster, and also the so-called north-south traffic from the outside and to the outside again. And a tool like NeuVector, like now the tools get a bit different because of the technology they're using there. What NeuVector is doing, it looks directly at the network stack on the Linux kernel level, and sees every TCP or every network package before it even reaches your applications. And it already knows where it's going to go to and can then say, hey, I can first of all see everything, and then you can limit it so that, for example, this container here or this pod here can only speak to this pod. So let's say this is a WordPress pod and this is a MySQL pod, the database for WordPress. And then you can say, okay, incoming traffic from this WordPress should only be allowed from the internet. Because why would everything else call an internal WordPress blog? It's not necessary usually that some microservice internally in the same cluster calls WordPress directly, if you're not automating it with an API or so. And then outgoing traffic from this WordPress pod is only allowed to MySQL, to the MySQL pod. And the MySQL pod only allows incoming traffic from WordPress and not from anywhere else. And there's also no outgoing traffic allowed from the MySQL pod. Because why? Why would you have outgoing traffic there? Like, of course, outgoing traffic does not mean that the response from MySQL back to WordPress is blocked. It's outgoing means that a new connection to an outgoing external system is blocked, or another system inside of the cluster. And what NeuVector then also can do is not only look at who connects to whom, this is like layer 3, 4 in the OC stack, but also what protocol are you actually talking about on this connection. So NeuVector not only sees who connects to whom, but also it sees the content of every package so that you can do a deep packet inspection and, for example, say, on this connection from WordPress to MySQL, I'll only allow MySQL protocol and not HTTP, DNS, or anything else. And then it could even look deeper into the packages and also say, hey, I know this is like an SQL connection, so maybe it makes actually sense to scan for SQL injection payloads. Whereas it probably doesn't make sense if it is like some other protocol, like a DNS protocol. This probably doesn't make any sense to scan for SQL injections on DNS protocol, right? So instead of scanning just everything, and for every vulnerability possible, you can selectively scan where it makes sense. And you can also limit the amount of processes that you are executing inside of the container. I'm losing my mouse cursor here. Okay. I actually wanted to skip over that because I already did this. So, sorry about that. So I said also that you can automatically learn all these rules. The way NeuVector is doing that is that you can run your whole system, your whole cluster, or individual containers or group of containers in different modes. The first one is the discover mode. In the discover mode, NeuVector learns new behavior. So every time there is a new network connection or a new process execution or a new file access, a rule is automatically being created for you. It's probably not good to run this mode in production where an attacker could be, because then you're learning what the attacker is doing. Of course, you can also review these rules and then selectively delete some or add new ones to validate them. So you can still manually go in there. If you're happy with the learned rules, you can either your complete cluster or individual pods or groups of pods put into either a monitor mode. Then NeuVector stops learning things. And if now something happens, a process execution, a network connection, or file access that is not covered by rules, it will still work, but you'll get an alert. So that is kind of a good thing if you're unsure if you did everything correctly. You don't want to break stuff, but if you want to know if something happens, and then you can react on it and maybe put something into quarantine mode or actually change it or actually block stuff. And the last mode is the protect mode. There also, NeuVector does not learn anything anymore, but if now something is happening that is not covered by rules, again, process execution, file access, or network communication, you get an alert, and also it's directly blocked, and also directly blocked at the kernel level. So the earliest point possible. That may sound complicated, so let's actually have a look at this, and I want to show you that it's actually maybe easier as you think. Okay. Is the font size large enough? If no, okay. Also in the back, perfect. If at any point in time it gets too small because we're going to a new tab, please just shout at me and tell me, and I can increase it. So what I prepared here is I have Kubernetes cluster. In this case, this is running in Rancher as a Kubernetes management tool. Does not matter, NeuVector runs in any Kubernetes cluster and also supports just Docker containers or Podman containers on single systems. And you can also use it with Docker Swarm. I'm not sure about Nomad. I would need to look this up. But I prepared, in this case, a Kubernetes cluster here. It is running on DigitalOcean. Also doesn't matter where it's running. It just needs to be a cluster, in this case, a Kubernetes cluster. I also installed already NeuVector in here. NeuVector is inside of Kubernetes, very easy to install. It's just a Helm chart that you install like any other application. There's also pre-made Kubernetes manifests and customized packages that you can use. And if you're running it outside of Kubernetes, just on a Docker host or a Podman host, it is basically a container that you run additionally on each host. I also deployed a small example application inside of my cluster here. And I'm specifically using now the UI of Rancher and not the kubectl commands to, if you know Kubernetes, that you can still visually follow here. So this application is a small online shop with lots of different microservices. You can see here is a front end and an email service and a currency service and a checkout service and so on. I also can quickly show you the interface. So this is the online shop, and you can click here on the product page and fake buy stuff if you want to. Maybe important for later, there is also a small load generator here that constantly does requests against the online shop that helps me then actually showing that something is happening. NeuVector is installed inside of the cluster, so let's open up the UI and actually see how unsecure and how bad things is. And this is basically now just standard installation. I didn't configure anything yet, so this is what you get when you directly after you installed it. And for some reason, it wants me to change my default password. It doesn't matter. So you can already see, first overview, security is very poor. There's a high security risk, so let's dive a bit more deeper into why that is. Let's first look at all the scanning results. And you can find this here under assets, and NeuVector actually scans not only the containers, but also has a look at your Kubernetes distribution, if there are any CVEs in there, that's fine. It also scans all the packages that are directly installed on the host system. So this is not running something running inside of containers. This is what is installed directly on my very old Ubuntu 20.04 image. And you can see tons of vulnerabilities in AppArmor, DNS utils, probably curl is somewhere in here. Git even has vulnerabilities because it's like a very old image that I specifically choose. Otherwise, it would be boring to see everything green, I guess. And I can click on every CVE. I can get the details there to judge, is this something I want to actually act upon immediately, or is this something that has time until the next patch run? Because, yeah, Git is installed there, but nobody's executing Git, hopefully, on a production system. So maybe I even want to uninstall it, or it's fine if it's there because it's not used. And I can wait a bit. Next to CVEs, I also have a set of compliance rules that NeuVector scans for to see if my nodes and my containers are configured according to best practices. NeuVector supports multiple compliance standards. That could be something like a NIST, HIPAA, GDPR standards, and then you can configure to your liking which one apply to you or not, and you even can create your own. And these are, for example, things, I did not harden my cluster here, so there are weak ciphers, for example, used in some certificates, and NeuVector can tell you about that. Next are all the containers that are running in my system. And you can see here, I'm just making this column a bit bigger. These are now actually containers and running on my production system. You can see, for example, this recommendation service here. It has one server container inside of this pod, and there's also tons of security vulnerabilities because I'm using very old base images here in an old version of the application. And there are also compliance issues. In this case, it is that file permissions inside of the container image are way too broad and broader than they actually need to be. I also can hook up my external registries here. So that could be anything like a Docker registry, JFrog Artifactory, OpenShift registry, Sonatype Nexus, GitLab, GitHub, or whatever. And all these scan results I not only can see here in the UI in like lists, I also have big reports for that, so that I then can say, hey, these are all the CVEs in my system, so these are the nodes and containers affected by that, and I can even export this as a PDF to send then to like a manager and auditor saying, hey, this is the state, and it's maybe easier consumable for a manager as a PDF than that UI. I of course can also say, hey, this CVE I'm actually not interested in, I just accept and ignore it, and please don't report that anymore as well. Same for compliance. And of course, there are also notifications, like every time a new thing has been scanned and I'm deploying something new, I get also a scan report. Well, this is not something here. The product catalog service, for example, here has some with all the CVEs, so that I can, for example, have a Slack message saying, hey, something new was scanned, something is in production and has a CVE, you maybe should do something about it without looking at the UI. So that's scanning. It gets more interesting now with the runtime security part. And let's look again at our online shop. And let's maybe specifically target, let's do the front end. So this here is my front end pod of my web service that provides the web UI. And you can see currently it's in discover mode, and it already learned a lot of rules. So for example, it learned that there is a pause binary that has been executed that is a part of Kubernetes, of how a Kubernetes pod works. You will find that everywhere. Then there is something like a run-C binary being executed. That's interesting. And the server binary, which is the binary that actually serves the web application. I think it's written in Go in this case, the front end. At least the web server that powers and serves the JavaScript and HTML is written in Go. So let's make, and there are also some network rules that have been learned. There is nothing much surprising here. The front end talks with a lot of other microservices. It does this via HTTP within the cluster. So this is internal communication from the front end to the checkout service. Also, the nodes talk with the front end. These are health checks that Kubernetes is doing to see if the front is actually up. The load generator talks with the front end, also not very surprising. And yeah, it's basically just, and the ingress controller, this is external traffic now coming from my browser through an Nginx reverse proxy ingress controller inside of the application. So nothing surprising here. Let's maybe change that. And let's go back into Rancher, and let's look at my front end here. And I'm just now executing a shell inside of the container. So this is now running SH inside of the container. It's basically kubectl exec, what I just did. And now I have a shell and can start looking what is inside of the container, debugging and executing commands. And I know that I have wget in here. I don't have curl because that's not part of the image, so I'm using wget. And let's just do a request to google.com. And it worked. I could download the index HTML file, and I actually got a response, so I have a network connection here. So let's see if that actually was learned. So first, let's look at the process profile rules, and you can see it learned SH. That was me opening up the shell, and it learned that wget was executed. And if you go to the network rules, we should now also have a new network rule. Yeah, there's a network rule that the front end actually did a connection to an external system. In this case, NeuVector automatically learns that it now allows every external system, but I also can then limit this to certain IPs or IP ranges if I want to. So let's maybe change this mode and let's switch this to monitor mode to see what happens then. And let's go back to the process profile rules and let's just delete wget because that was me debugging. I actually don't want to allow this. If we do the same thing again, it gives me an error because I can't download the index HTML file again because it exists, but the connection worked. I can execute wget, everything worked still. But now if we go to the alerts of NeuVector, we got an alert that someone tried to execute wget, which was not covered by rules. It is a warning because we are in protect mode. And if we now do the same thing again in not in monitor mode, but in protect mode. Let's switch this over here to protect. And do the same command again. We'll see immediately that the execution of the process is directly killed by the kernel. And of course, we also get an alert there that says, hey, someone tried to execute wget, it was blocked, and that's why it's also critical. And now I can, of course, say, hey, now my application is broken. I quickly want to add the rule again to allow wget. So let's change this and allow this again. And you can see this is all very immediately, so I execute it again, it works again. And then instead I, for example, can say, hey, let's maybe remove the network rule that allows communication from the front end to external systems, because that's not necessary. So I don't want to allow this. Okay, has been deployed. So now the execution of the command still works, but now the connection to the external IP address google.com actually hangs, and it will probably time out with the default timeout that wget has. So let's cancel this maybe. And of course, I also get an alert here saying, hey, someone tried to connect from the front end to google.com, and that was blocked. And I also have here the IP address and everything, so I can check this now and analyze this, why that happened. Instead of only seeing this in lists, NeuVector can also visualize the whole system graphically. That can also help with actually getting an overview about what happens. So here you can see every bubble is one of the applications, one of the deployments in my cluster. I have here, for example, my front end. You can also visually see there is a red bubble, which means there are security vulnerabilities inside of this application. But it's also green, that means it's currently running in protect mode, whereas everything else is running in discover mode still. And you can see then these lines here are lines of communication. So for example, you can see here the incoming request from external systems from my browser inside of the front-end pod, but you can also see a red line here. And this is the traffic that is outgoing that has currently been blocked, and I also see all the sessions here. And I actually also see that like the same connections were open before because I did have the rule in place. So also from here, of course, I can do things like change the mode here. And maybe two other things that are kind of interesting what I can do is, because NeuVector can block stuff, I also can, if I want to, as an immediate action directly quarantine an application, which means now everything incoming and outgoing is blocked. This is kind of like last resort. You get an alert, some attacker is in there, you want to quickly take something offline without having to go somewhere, scale something down, wait for containers to be then stopped, and you can just quickly say block everything. So I should now, maybe don't do a Postgres. Yeah, so my application is offline now. And I, of course, can also quickly unquarantine it again if it's not fine, and my application should be online again. And maybe there is no health check and I have to wait for 10 seconds or so, but it should be up momentarily. Yeah, now it's up again. It was just because the health check is only executed every 10 seconds. That's why it was still marked offline. The other thing that can greatly help you with analyzing and having visibility what happens is, because NeuVector sees every content of every package coming in, you can also quickly do a complete packet capture for an application. So what this is now doing is capturing every package that comes into the container and goes out, and only for this front-end application and not like everything. And when I'm happy with it, I can stop this, generate myself a download link, and then I get a pcap file, and this is a format that, for example, tools like Wireshark understand, that can now visualize every connection, every package that has been made. And you, for example, see here, I don't know if I can increase this? Yeah. You can see here is a GET request, an HTTP GET request to some product page done from the load generator, and I can look into all the headers. You can see this is a Python load generator now that did this, and I can even see the complete body, if I response body, if I wanted to. So that can also help me a lot with forensics. Of course, you can still also do this by finding out on which node this container currently runs. Then you have to SSH into the node. You have to find out with which keys you actually can access this node. Then you have to find out how to actually run TCP dump with the right parameters to only see the traffic over that one container, and then I'm completely lost because I have to Google that and probably need like 20 minutes to find out how that actually works. So that's maybe a bit faster and nicer. Another property of NeuVector seeing the whole content of the TCP packages is that it allows you to create web application firewall rules. So one example I brought here to show you how that can work is a log4shell attack. So what I'm doing with this curl command here is I'm doing a post request against our online shop application here. And in the user agent header, I actually have a payload that would be a log4shell attack. And yeah, that worked. I get an error from the application back because it doesn't expect a post request here. But you could imagine that this is a web frontend application. It probably has an access log. In this access log, it will probably store the user agent as a string. And then there may be some Java application, like, I don't know, Logstash or Elasticsearch or whatever, that takes this and does something with it. And then we could have a log4shell attack there. And maybe get a shell. So let's try to block this. And let's go into our security policy groups here again. Let's look for the front end. And in here, I also have a tab for the web application firewall. And I already prepared a sensor here that detects log4shell payloads. Basically, these sensors are regular expressions that you can execute on the traffic. So sensors are, this is also not something unique to NeuVector. This is true for every security and web application firewall. These sensors are usually only as good as regular expressions are. There are more sophisticated tools that can then also do like some statistical analysis, but then it gets really complicated. If you have questions about that, we can also talk about this later. But for here, I'm just doing the more simple thing, only for incoming traffic. Oops, I should have clicked save. Only for incoming traffic inside of a, sorry. Inside, only for incoming traffic coming inside of to the front end service, I want to now scan for log4shell attacks. And I activated now the sensor, and if I do the same request again, you can see it will now time out. So I don't get a response back. I see still the request headers, but I don't get any response back. And at some point, I will get a timeout from curl probably. And if we now look at the notifications and security events, you can see that here the web application firewall rule was just triggered. The traffic is in this case coming from the Ingress controller, again the reverse proxy that sits in front of it, and going to the front end, and you can see that it was a log4shell attack. And if I want to do more forensics here, I also have a packet capture directly here that shows me, again, this request in detail. And you can see, for example, in the request headers, this attack vector here in the user agent. Okay, there are tons of more things you can do here that would probably take another hour or so to talk about. There's tons of ways how to automate all of that. I clicked a lot of things together now, but of course you don't want to do this in production for 500 applications. You want to automate stuff. That is all possible. We didn't have a look at admission control yet. We didn't have a look at a lot of reporting mechanisms that are in there. So there is a lot more to discover. And again, the good thing there is that it's free, it's open source, right? So if you want to, you can go to documentation and start testing it out right after this talk or on Friday when you have some time. So there's actually no reason for not making your containerized production systems more secure. There's no reason why you have to say, yeah, but I have to buy like this expensive software and spend like $10,000 a year or month or whatever for a security product. We can still help you with enterprise support if you want to. You can also talk to me about this, but if you don't want to, you can also just use it for free, open source. So with that, thank you very much for your attention. I hope I got you interested in container security and actually making your application more secure. And yeah, we can have some questions if you want to. Yeah.
One sec.
Just a quick one. Is there a performance hit from this?
Very good question. So I would answer this in two parts. First, NeuVector runs some containers to do its magic, right? And it, for example, needs to run one container on every node of a Kubernetes cluster or of every Docker node in order to do the enforcement, actually see the traffic. So first of all, you need a bit of resources on every node just for NeuVector to run. That's more kind of like a gigabyte of memory per node, and maybe CPU-wise, it's actually not that much. It's maybe a couple hundred milli-CPUs or something like that. And then you need a bit also for the UI and control plane in terms of CPU memory. In a very small environment, that actually could mean a lot of resources additionally, comparably. But if you have a bit larger cluster, like 5 nodes, 10 nodes, you probably won't see that. And it's also resources and money well spent, because it's same like monitoring. Of course, that also costs a bit of money to run, but otherwise you are blind and you don't see anything, you don't know when it's slow or something, and here's the same thing. Otherwise you don't have any security. The second part of the answer to the question is what actually happens in terms of additional delay on my network connections. When NeuVector is in monitor or discover mode, so when it's not blocking something, the overhead on the network connection is 0, because it's kind of like a tap on the network stack, similar to what TCP dump is doing. If NeuVector needs to block something, you have an overhead. Without any web application firewall rules, the overhead of having NeuVector within the system and then maybe blocking something, from our measurements, is about 1 to 2%, which means in most systems it kind of gets hidden in the background noise of network connections. It could, of course, mean if you do like, I don't know, trading and every nanosecond counts, then this is something to think about, if you maybe actually want to run something blocking there. And please also, if performance and network performance is really critical for your application, and then also, of course, benchmark and measure it yourself, right? Don't just trust me that it's 1 or 2% and it's fine. We have lots of large customers that benchmark this and agree with us, but yeah, your system may be different. And then if you create lots of application firewall rules, it also scales a bit horizontally up. The more regular expressions you're checking, you also need a bit more CPU and time, which is also one of the reasons why we recommend not completely going overboard and adding all the sensors everywhere, but only adding sensors where that makes sense. Yeah, great question, thanks. Yeah, there in the back.
Okay. So you talked about level 7 packet inspection and in regards to SQL injection vulnerability detection. How does that work? Is that like a heuristic-based thing of going, if you run empty string equals empty string, that looks a bit dodgy, or is it actually doing something clever?
It is, so on a high level, it's looking at the queries that you're doing and trying to detect SQL injection. It's probably not going to be 100% foolproof to find everything, because SQL injections can be quite sophisticated and complex, but it's more analyzing the query and seeing if there's something dodgy happening there.
Do you have a rough idea of what sort of thing would be dodgy?
Like, there is certain things you can, for example, look for where you have like a string that is directly string open and directly close again, and then you have some comments and then something like that.
Yeah,
right?
so the example I gave,
Yeah.
which was...
So it's looking for these kind of things.
Okay, so it's pattern matching certain things. Okay, cool.
And also, you still should use not only trust that, security is like layers. This is like one layer that can help to protect you. You should also use static analysis to find SQL injection possibilities in your code where you forgot to do prepared statements. So that you should do both, right?
Yeah, so using like the literal string for making sure that the SQL is defined by the developer and contains no user input. Yeah, sorry, it's my little pet project, so thank you.
Yeah, so definitely do that as well. Security is always about layers. No layer is perfect, and I like the analogy of security layers as cheese, and every layer of cheese has some holes in it, and you just have to add enough cheese layers upon each other so that you don't see through the holes anymore. And security is very similar. Nothing is perfect. You have to do a lot of things, and this is one of them that can help you.
Thank you.
Yeah.
The deep packet inspection is really quite cool, but that obviously gives you the trade-off that you can't terminate your encryption at the pod itself, because otherwise NeuVector couldn't look in and actually see the SQL, etc. Yeah. Do you have a view on the trade-offs between choosing to terminate your encryption at the pod or whether terminating outside so NeuVector can work?
Yeah. So what NeuVector is not doing there is it's not unpacking TLS and breaking TLS. Some security tools do that. We think it is bad practice to break TLS. And then lots of security people argue about that. That comes, of course, to the downside that if it's encrypted, NeuVector will see the encrypted traffic and will see that it's encrypted. It can also ensure that it's encrypted, so to not allow unencrypted traffic, so that's also nice, but it can't look into that anymore. It depends a bit also where you do actually the encryption. Oftentimes, incoming traffic is encrypted until the ingress controller. The ingress controller is doing TLS offloading, and then actually inside of the cluster it's unencrypted. So NeuVector would not see the traffic content coming into the ingress controller, but it would see the traffic content between the ingress controller and your application pods. Maybe then if you want to encrypt also traffic between applications inside of your cluster, sometimes you only do this during transit between nodes with something like WireGuard. NeuVector would still be able to see this then coming into the pod. Or you do this with something like neutral TLS and service meshes, and there you also see that the traffic between the service mesh proxies is encrypted, but then within the pod between the application and the service mesh proxies again unencrypted. Then you could also analyze it there. If you do full end-to-end encryption directly from your application source code to the client, then it's fully encrypted and you can't see it. And I think the right answer also depends on the use case and context and security level you want to have.
Any more questions? Okay. Well, thank you very much, Bastian. And